Now, question 6 is arguably the most challenging question on this week's homework. So we have a figure that shows a superposition of two sound waves, and we want to know what are their frequencies. So the figure in the book looks something like this. I did not, in fact, draw the appropriate number of waves you should have. I started trying to, but then I realized I was going to run out of room on the board. So we're going to go with this, but the book has a much better illustration, and when it comes time to count things, you'll want to refer to the book's figure instead of this one. So if we look at this graph, we can see we have pressure, change in pressure versus time. And if we want to figure out the individual frequencies, the first thing we're going to want to figure out is our beat frequency. So we know that the beat frequency has related to how many cycles of our big wave we have in a second. And remember that when we're talking about beats, going from a soft spot to another soft spot, so soft, loud, soft, that's a one beat, or going from loud, soft, loud, that's also one beat. So going from this point to this point, that's one beat. Well, how many cycles do we have? Just the one, and it takes us half a second. So if we want to find our beat frequency, we're going to have F beat is equal to, we have one cycle in half a second. So our beat frequency is going to be 2 hertz. Now, alternatively, we could have looked at how many cycles we have in 1 second, and we have 2 cycles in a second. So we could have used 2 cycles over 1 second, and we'd still get 2 hertz. Now, once we know our beat frequency, let's recall how it's related to our frequencies, our individual frequencies. So we know that F beat is equal to the absolute value of F2 minus F1. Now, this on its own isn't enough information for us to solve the problem, but we do have another equation at our disposal. So remember that our oscillatory frequency, F sub OSC, is equal to 1/2 times F1 plus F2. If we can figure out what our oscillatory frequency is, then we can use the system of equations to solve and figure out what F1 and F2 are. To find our oscillatory frequency, this is where we'd have to turn to the book's illustration, because we have to count how many cycles we have in a second. So we're just going to count up all these cycles. It turns out there are 50 of them. There aren't 50 on the board here. You know, if you were counting mine, would have, we go peak to peak, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13-ish. The book, though, has 25, so in half a second and 50 total. So our oscillatory frequency, that is going to be 50 hertz. And again, you just count the number of cycles that you have in 1 second, and that will give you the oscillatory frequency. So we're looking at the little purple oscillations instead of our kind of big envelope. That's what we started out with for the beat frequency. So from here, we're just going to do some algebra. So I'm going to clear the board, and we're going to rewrite our 2 equations, and we're going to use some algebra to solve. So these are our 2 equations here. Recall that the choice of which wave we call F1 and which one we call F2 is arbitrary. So we're just going to say that F2 is the bigger one, and if F2 is the larger one, we can drop our absolute value sign. So we're going to rewrite this as F beat is equal to F2 minus F1, which is 2 hertz. Now I'm going to take this equation here and multiply both sides by 2. So if I multiply this side by 2, that's going to get rid of our 1/2. Multiply this one by 2, we get 100. So if I just rewrite this equation right down here below, we're going to have F2 plus F1 is equal to 100 hertz. And we're just going to add these 2 equations together because that's going to get rid of our F1. So maybe this is recalling some stuff you might not have seen a lot since Algebra 2, but if we have a system of 2 equations, we can just rewrite them. So we have, when we add them together, we're going to cancel out this F1 term. And so we're going to be left with 2F2 is equal to 100 plus 2 would give us 102, which tells us that F2 is equal to 51 hertz. Now, to figure out what F1 has to be, we're just going to plug that into this equation and rearrange. So we're going to have 51 hertz minus F1 equals 2 hertz. We're going to bring the 2 hertz, subtract 2 hertz from both sides, add F1 to both sides. So we're going to have F1 is equal to 51 hertz minus 2 hertz, which works out to be 49 hertz. So there's a lot to question 6. It's a little bit complicated because it's very graphical, but that's how you would complete it.